All right, we're going to take a look at some more advanced solving techniques for these trig equations. You see something up here that's a little unnerving, that sine of 5x equals negative 1/2. The idea is when you start putting numbers here, when we start multiplying inside a function, remember what that does. It will horizontally stretch or compress your function by a factor of this reciprocal right here. So in this case, we're going to horizontally compress the sine function by a factor of 1/5. Now, how does that change the game? Well, when you graph normal sine, here's 2 pi, here's pi. When you graph normal sine, what's happening when we try to solve this? We've seen this before. When does it equal negative 1/2? So, stop being lazy here. That was a nice miss. All right, negative 1/2 would be right about there. You would draw your line, horizontal line through negative 1/2, and you would see, okay, we got 1, 2, 3, 4, 5 intersections that we can see. If we go 0 to 2 pi, you can see we have 2 solutions. Well, if you think of what sine of 5x is going to do, that's going to horizontally compress your graph by a factor of 1/5. So instead of 1 period from 0 to 2 pi, you're going to have this thing going through 5 of these graphs. I'm kind of exaggerating here, 2, 3, 4, yeah, whatever. Okay, I missed that one. But the idea is it's compressing the graph horizontally, which means you have a lot more solutions between 0 and 2 pi that are now occurring with this particular function, that sine of 5x. So the question is, how do you get those solutions? Well, that's kind of what we're going to take a look at here. All right, to do these particular problems, we're going to need a little substitution. And what we're going to do originally, I'm going to start off and replace that with a different variable. Something like, say, new variable, let's call it u. U equals 5x. If we let this happen, then this equation becomes much simpler. We would get the sine of u equals negative 1/2, just a simple substitution. So if we let u equal 5x, then we have to solve the equation sine of u equals negative 1/2. Now solving this, we've seen this many times before. We go principal values, you're looking at the sine inverse of negative 1/2, which will be negative 30 degrees or negative pi 6. Right? Let's go with negative pi 6. We'll go radians, just to be different. All right, so negative pi 6, we could go with our principal value. We'll do it in terms of radians. Let's take a look at 0 to 360, just so we can easily get the radians here. 0 to 360, quickly go through this. Negative 30 is no good, but we can use it. For 330, or where else is sine negative besides quadrant 4? Sine is negative in quadrant 3. With a reference of 30, you're looking at 210. Right? Make a long story short, in terms of radians, we were talking about 11 pi 6 and 7 pi 6. All right. Now, the solutions in terms of radians to this equation, yeah, it's 11 pi 6 or 7 pi 6. The problem is that's what u equals. So we're going to say u equals, let's just draw arrows. That might be easier. U is equal to 7 pi 6. We'll write that one first. Or 11 pi 6 if we talk about between 0 and 360. Well, if you remember, u was equal to 5x. So we're going to have a lot more solutions, and we're not even necessarily saying that these are going to be solutions to the original, and in fact, I don't believe they're going to be. So what we're going to do is we're going to list out a bunch of multiples of these, angles that would be coterminal, right, with u, and you'll see why we're doing this in a minute. Now, to get angles coterminal with these, if we're talking in terms of radians, which we are, we have to add or continue to add 2 pi. Now, 2 pi with a denominator of 6 will actually be 12 pi 6. That'll be easier to add. So 7 pi 6 plus 12 pi 6 is 19 pi 6. Plus 12 pi 6 would be 31 pi 6. I can do the math. Plus 12 more pi 6 would be 33 pi 6, which does go in lowest terms, so 33 pi 6. Let's keep it that way for right now. Add another 12, we're looking at 45 pi 6. And another one, I mean, we could keep going here. I'll just do one more. 30, 40, 57 pi 6. It's going well. 57 pi 6. The whole idea is I'm listing these out for a reason, because u is going to be replaced with 5x very shortly, and these are all going to get divided by 5. That's the idea. And the question is, how many of these do we need? Well, once we go past our 360 limit or our 2 pi limit, and we'll see here. Now, that guy's already way past. So is this one. I mean, you just keep going further and further past, but you got to keep in mind we're horizontally compressing this thing. So each of these are going to get divided by 5. So each of them is going to have a denominator of 30 now. And with the denominator of 30, you're going to have many solutions between 0 and 360. How many we're going to need? I think the thing is we're going to need about 5 of them, right? Because after that, I think we're going to be over our 2 pi limit. So let's see. No, we'll just keep going. So 11 pi 6, we're going to add a 12 pi 6 to that one. We get, what, 23 pi 6? Add another 12 pi 6, that's 35 pi 6. Another 12 puts us at, what, 37 pi 6, 47 pi 6. Another 12 puts us at 59 pi 6. Another 12 puts us at 71 pi 6. Alright, for some reason this doesn't seem right. Did I not do my 12? 31 and 12. 43. I knew something was wrong there. Knew it couldn't be a multiple of 3 after that, but I just kept going with it. Alright, 12 and 43 is 50, 55 pi 6. And 12 puts us at 67 pi 6. And I really should be putting ... Just how many are we going to need? Well, we'll find out here in a minute. Because the u is going to now be replaced with a 5x. So now, these are representing 5 times our actual solution x. In other words, think of this as, 10 different equations where I'm saying, okay, 5 times x is equal to, for example, 7 pi 6, just taking the first one. Well, how do you solve that? You divide both sides by 5 or multiply by 1/5. X is equal to 7 pi 30ths. That will be one of our solutions. And we do that for all of these. So basically, we're just dividing each of these by 5. The 5 is just going to multiply to the 6 and make for a denominator of 30. So if u is 5x, then x is going to equal, let's go, 7 pi 30th is one solution, 19 pi 30th, 31 pi 30th, 43 pi 30th. The question is, when do you stop? Well, you got to stop once you go over the 2 pi threshold. 30 into 43 is still less than 2, so keep going. That's 55 pi 30th. 30 goes into 55, still less than 2. What do we got? 67 pi 30th. 67 pi 30th, and you can see right there is where we run into trouble. 67, 30 goes into 67, 2 and some change, so that is where we can stop. All right, going the other direction. Divide that by 5, you got 11 pi 30th, 23 pi 30th, 35 pi 30th, 47 pi 30th, 59 pi 30th, ooh, real close, 71 pi 30th is over the threshold, 71 pi 30th, forget about the pi, 30 goes into 71, 2 and some change, so that's, like I said, that's over our threshold. So the bottom line is, how many solutions you got? Between 0 and 360, you got 10 solutions. 10 solutions to this equation. Whew. These are rough. These are definitely rough.